So I went ahead and I created a few of the files. So I created the FIFO, I created that, and I created this one in here. So let's start with the register file. So the register file, which is just a 2D array, we have covered it in a previous video as RAM. It's exactly the same code. You will see that I have the clock, the write enable. This is the only change I did. It used to be write enable, now it's like write underscore enable. And the reason why I changed it so that I can match the naming on the figure here on the side. And the same, I have a read address and a write address because this is a dual port, one for read, one for write. And of course I need a write data as an input and a read data as an output. And I define the memory in here like we did before. This is the 2D memory or the 2D array. And then I decided to make it a write will be synchronous while the read is asynchronous. And the reason why I decided to go with the asynchronous read is because we're designing the first word fall through FIFO, and I wanted basically the word that comes out of this particular data point in here to be available right away. So it should fall through, like even within the same clock cycle or after the first clock cycle of writing something when the buffer is empty. So this is why I'm doing that. And of course, because I'm not following a BRAM template, this will not be implemented as a BRAM. You're going to see it's implemented as lookup tables. If I choose to implement it as a BRAM, basically if I want my FIFO to utilize the BRAM on the board, well, then I'm going to have to change this to match the template. And chances are I will not be able to do the first wall fall through readily because this has to be a synchronous read. So there might be a little bit of changes. But for simplicity, today I just wanted to use a code that we've covered before. So I'm just going to do with the asynchronous read. Okay, so we go then to the controller. Okay, so what we have is we have the code ready for the register file. What we need to do is we need to go for the Fifo Controller. Well, the Fifo Controller is just a finite state machine. So that's what it is. I just didn't cover it as a finite state machines, but effectively it is. What it does, it takes a couple of inputs, which are write and read, and it takes and gives me a couple of status signal, which are fall and empty. And of course, it also gives me other outputs, which are the write address and the read address. However, the end user is not going to see it. But now we're not thinking about the end user of the whole FIFO. What we're thinking about is just the controller. So what you're going to see in here is I have clock and reset as usual, and reset because I have a finite state machine. I need to reset it to its initial state. And generally speaking, you're going to see it's as if I'm resetting all the pointers to 0, and I'm telling it that the FIFO is empty and it's not full and so forth. Of course, I have these signals, just basic definitions like we've seen before. And something I did not mention in here, so the register file, I made it parameterized so that it's actually generic so that we can expand the FIFO as much as we need. So in here, by default, I put the address width at 3. That means I need 8 location. And the data word is going to be about 8 bits, but I can change it. Okay, I can definitely change it. It's up to me to change it, and you're going to see it. So in the Fifo Controller, as you can see here on the figure, the Fifo Controller does not deal with the data at all. It just controls the flow of the data. So what it needs just the write address, or the read address and the write address in here. So you're going to see that the only parameter it needs is how much is the address width. Because these are basically the R address and the read address and the write address are going to be the pointers, and I need to figure out how many bits they should be. And by default, I put them at 3, exactly the same as here. That's what I did. All right. Then the next in here is I defined a few of the registers. So we're going to have, instead of dealing directly with the write address and the read address, what we're going to be doing is we're going to call them pointers so that it matches the figures we've covered in a previous video on how the circular implementation works. So I have a write pointer, and of course, because it's a sequential circuit, I'm going to think about it as a current state and as a next state in here. So the same goes with the read pointer and the write and the read pointer next. The full and empty, I'm also not going to deal with them directly in here, or actually I will deal with them directly because they're just 1 bit, so it's okay if I deal with them directly. And frankly speaking, I can just write, instead of the write pointer, I can directly go with the write address and put here write address next and whatnot, but I just decided to call them pointers because this is what we did in the figures before, so we're just going to keep it this way. So, okay, so we have the full and the empty. Okay, so now we jump into the implementation itself. And so again, we're dealing with a sequential circuit, so it has to be an always FF. And then here, I'm gonna deal with the positive edge of the clock. That's what I choose. And the positive edge of the reset so that I make it an asynchronous reset. Okay, so let me just probably, if I do this, this is a little bit better. You get to see it. Okay. So in here, I will have the following. What I'm going to do is I'm going to ask if it is in the reset. Basically, if I issue the reset, what do you want me to do? Well, effectively, what we need to do is we need to make sure that the write pointer is pointing to location 0, the read pointer is pointing to location 0, and of course we need to think about the full and the empty. So initially, of course, it's not going to be full, so I'm going to put 1 bit 0 in it, and it will be empty initially. That's how I want it. So if I'm resetting the circuit, if I'm resetting the FIFO is empty initially. So I'm going to just basically put a 1 in the empty. Again, full and empty are basically just being implemented. They're status flags, and I need to keep track of them because it's pretty difficult to actually know when it is full and when it's empty unless I'm keeping track of it while I'm writing and reading. And you're going to see how we're going to change them shortly. Okay, now if I'm actually in the actual implementation or actual operations of all these registers, you're going to see that all I need to do is just update the current value with the next value, and that's about it. So I went ahead and I just wrote it. Okay, so I'm just keeping basically, I'm updating the write pointer, the read pointer, the full and the empty with the next states. Okay, so now I need to basically figure out what the combinational part, basically what should be next. Okay, and the combinational part is where the meat of this particular FIFO pointer. This is actually where the whole implementation is. And of course, because it's the next logic, so it's going to be an always combinational. Okay, I'm going to do begin and end. And generally speaking, what I usually do with combinational circuits is I define the default values for most of the registers I have in here, just in case I actually forgot to assign it in one of my ifs or case statements or for statements, so that it doesn't interpret any latches and I don't get any warnings. So what you're going to see is I will basically get whatever the right pointer next should be. I'm just going to make it the current value of the right pointer. I don't need it basically to change, and that's by default. Of course, I'm going to change it like to implement the FIFO, but by default, I don't want it to change just in case I didn't change it or I wrote some if statements or case statements that did not change them. Okay, so we're going to do the empty equals empty, and you can see that I'm basically just updating all of them together. So you might see that the code is going to grow pretty large, but I want you to see that all we have is we have a couple of registers, the read pointer and the write pointer, and a couple of flip-flops, which are full and empty. And I'm basically just controlling what the values inside them should be. Let's see a case statement in here, and I'm going to do an end case. And the case is the following. What I have is, in addition to updating the read pointer and the write pointer and the full neck and the empty necks, you're going to see, as you can see on the figure, they're all controlled with the read and write signal. That's what I'm going to do. So I'm going to have to figure out whether I'm reading from the FIFO, whether I'm writing from the FIFO, what signals it's operating. Again, this is a controller. It's a finite state machine. It takes certain inputs in and it issues certain commands to control everything around. Okay, it's just a controller. So what you're going to see me doing is I'm going to check the case of the write and read signals, and I'm just going to concatenate them so that I can have them within a case. So this concatenation is going to be a couple of bits, and based on whether this is 0, whether this is 1, and so forth. Okay, so the cases I have is I will just write the cases and then I'll figure out how to implement them. I have a 2-bit, so I can basically say 0, 1, which is I'm just going to write next to it is the read case, and I'm going to do a begin and an end here. And of course I have a 2-bit, and well, I wrote them in the wrong place, so let me just take this in here, paste that in here, and we're going to take this in here. Okay, so 2 bits, maybe this time I'll deal with the write case. Okay, and then here I'm going to do a begin and an end. I'm going to fill the code later, and then what I need to do is the case when I'm actually reading and writing at the same time, exactly at the same time. And of course I need the 0, 0, which basically I'm not reading and I'm not writing. So what I'm going to do is I'm just going to catch it within the default. You're going to see with the 0, 0 I'm basically doing nothing. Well, why don't we go ahead and do that? Well, this just tells me there's no operations in here. Don't do anything. So let's figure out with the read. So initially the read is going to have to figure out the following. I can only read if the FIFO is not empty. So I need to check whether it's empty or not. So let's do that. So I will only read whenever I am not empty, which makes sense. I'm reading, so I just need to read when it's not empty. So if it is empty and you issue the read, I'm just going to say nothing will happen. I'm not going to do an else to this if statement, and what's going to happen is it's just going to take the defaults. So if it is not empty, I need to do something. Well, if I'm reading, I need to jump to the next location, or the pointer has to move forward. Okay, if it's not empty, that means there are certain values I can read. Okay, so all I need to do is I just say the read pointer next. The next value should it be the current value plus 1. And now you see why I use the pointer. It's just because I'm referring to the same idea. I just don't want to think about it as a write address and a read address. It might be confusing. So it's a pointer. So I'm pointing to a certain location. So a read pointer is going to advance. And because I advanced, I read something. That means the location I was currently at is available to me. That means the FIFO is not full anymore. So what I need to do is I need to make sure that the full next is actually set to 0. Okay, it's not full anymore. I just read a value. That means the location that I was at is available now. So the FIFO is not full, and something can actually overwrite that previous value. And by overwrite, I mean because it's still stored in memory. It's just I'm marking it as available. Now here's the deal with catching whether it's empty and whether it's full. Let's assume that you issued a read command and it was reading, and it read the last value that is stored in the FIFO. So what I need to do is I need to say, okay, if that read pointer, the next one that you're about to stop at, is the same as the write pointer, because the write pointer is stopping there, that means the FIFO next is going to be empty. Okay, again, take a look at these here, and you're going to see that this is the state from here. Let's say like I am actually at the read location in here, and I'm reading the last exact value. So what happened is I'm telling it, hey read pointer, so you are about to move to the next location. Okay, and I told it like this is the next location. So if that next location happened to have the write pointer in it, that means you are here and you're in the empty state, and I just basically raised that flag, which is stored in a flip-flop. This is how the read actually operates. You're going to see that the write is extremely similar. Okay, first I need to only write when I am actually not in a full state. So I need to check whether the FIFO buffer is actually full or not. So I can only write when it's not full. Okay, if it's full and I issue a write command, I should just ignore it. Okay, I can complicate this Fifo controller. For example, maybe a user would issue a write command for some reason or another and it's full, and the user did not actually check that the Fifo in here is actually full and issue to it. And this current implementation is just going to ignore that command. Okay, so if the system that is actually sending data in here decided to write, it can write, but then the Fifo controller is going to tell me, well, it's full. So what I'm going to do is I'm just going to ignore it, and I'm not going to tell that system that is sending me anything that I just ignored it, because it's the wrong from the user, because the user should check if it's full or not before sending another thing. Anyway, let's go back to the implementation. So in the implementation, I'm gonna only write when it's not full, and I'm gonna do the same exact thing. The write pointer, okay, the write pointer has to move to the write pointer, to the next write pointer location, basically to the next location in the FIFO. And again, now because I wrote a value, so if I wrote a value, that means there's at least one value in the FIFO. So that means it's definitely not empty. So I'm just gonna make sure that it is not empty. And again, now I'm gonna keep writing, and let's assume that basically we reach the location with this one in here. Let me just show you. So I am about to do that in here. So I'm currently here, and I'm gonna say, well, the next write location is actually it's number 1 in here, and it happened to bump with the read pointer. So what you're gonna see is now I'm gonna issue that it's full. So I'm gonna test the same exact thing in here. I'm gonna say, well, if I can just say the read pointer so that you don't confuse it. If the read pointer next, or actually I should change it because this is the write pointer next. The next value for the write pointer has to be exactly as the read pointer. You can see that now I can say that the full next has to be asserted. So next, what we need to do is we need to figure out what to do if I'm actually reading and writing at the same time. Okay, so I can definitely, because the read and write, this is I'm dealing with a dual port RAM or memory array. That means I can read and write simultaneously, and I should be able to do it. So what I will do is I will deal with the case. Both of them are basically I'm moving the pointers forward together. Let's do this. Next equals write pointer plus 1. I'm just moving the write pointer ahead, and I'll also move the read pointer next. I'm just going to move the read pointer ahead as well. I'm just trying to be a little bit more careful. So what I will do is I'll say, okay, what if it's empty and I'm actually at current location 1? Do I really need, like, if it's completely empty, do I really need to move both pointers from the 1 to the 2 and from the 2 to the 3? If you think about it, with the data that is falling through directly, if I'm actually in an empty location and I actually decided to write something to it, okay, so I am writing a value, so that value will be stored in here. If I'm moving the read pointer, technically I'm telling it, hey, the output should be whatever is on 2, not whatever is on 1. So I might get a mistake. So what I'm trying to say in here is I will deal with the case, the only special case where it's actually an empty FIFO and I'm reading and writing at the same time. So what I'm effectively doing by reading and writing at the same time is I'm writing at value, okay, and I'm just pointing, it's gonna go directly to the output of the FIFO buffer. So technically I shouldn't move the read pointer at all. So what I'm gonna do, if it's empty, I'm gonna say, well, the read pointer and the write pointer are gonna stay in the same location. Because if you issued a read pointer, that's technically telling me that this location is available again. So what I'm gonna do now is I'm gonna say, well, if it is an empty FIFO, you need to do something a little bit different, okay? And otherwise, I'm gonna basically put these in the beginning and end here. So now, if it's empty, what I'm gonna do is the right pointer next has to stay in the same exact location, okay? And the read pointer next has to stay in the same exact location. And of course, I could have like rewritten that code a little bit differently because these statements are already here in the defaults. So I could have just basically tested that if it's not empty, you do this. Otherwise, just ignore it. And that's the beauty about the defaults because they will capture these cases. But anyway, I just want it to be a little bit more clear. So I'm just going to keep it this way. So all is done, but I was dealing with pointers, read pointers and write pointers and whatnot. However, my output in here, there should be the write address and the read address. All I have to do is just rename the read pointer and the write pointer together. I can do them anywhere. I'm just going to do it here. Basically, I'm going to say a continuous assignment in here, and I'm going to just basically deal with the outputs. And again, the continuous assignment, if I'm doing something like this, I'm basically just renaming signals since I'm not doing any operations on them. And that's it. Now, all we have to do is just implement whatever is on the graph in here. And technically, I need to instantiate a couple of them in here. I already did it. And you can see it. I instantiated this guy in here, which is the register file. I instantiated the Fifo controller. And all I did, I basically just connected the wires together.